maybe even good afternoon or good night, I don't know. Nevertheless, today we're going to talk about INP, and let's also show myself. Well, we already, I guess, know that FID is being replaced by INP. We also have an interactive part in this webinar, by the way, so you can either join us today in a more interactive way by going to either mentai.com and submitting the code, or basically scan the QR code. You've got a few slides, the ability to, well, join our interactivity, our quiz questions during a few slides, but I'm already moving on for those that are maybe on a tight schedule. All right, first of all, what to expect today? It's not like I did receive some questions about, am I going to share some wins for specific platforms, or am I going to talk about specific plugins that you should use, etc. Or maybe even quick wins, but I am afraid that the fact is with INP, there are no real quick wins that I would typically advise in real cases. I mean, there are quick wins, but I'm not going to cover them because, once again, those would not be quick wins that I would normally advise to use. And well, I think we've got quite a broad audience, so I cannot really dive into specific platforms. Everyone is using different platforms out there, and the same applies to plugins as well. But I do hope to at least change the mindset today, so that you can, well, use the learnings today in future, well, yeah, performance optimizations or choices maybe. For those just entering, you can join our interactive session by going to either mentai.com and entering the code that you see in your screen, or scanning the QR code. So in both cases, you can use your mobile devices. Next to changing the mindset today in this webinar, I also hope to tackle any debugging anxiety. For example, well, yeah, performance panel can be quite overwhelming. The same applies to INP. Debugging INP can be a challenge as well. So yeah, what to really, well, once again, I also started at some place where it was a bit overwhelming to debug any JavaScript issues really. So I also hope to change that a bit as well. And if we have some time left, we can do some additional Q&A, maybe answering some questions from the chat and doing some tech talk as well. So let's move on. You can still join today in the interactive version by going once again to mentai.com or scanning the QR code. And for those that already joined and already use their mobile devices, I would like to know if I'm dealing with mostly technical developers today or technical consultants, etc., or if there are any, or if you have a less technical role, and we might have some. Well, I'm actually not sharing the screen at all, so let's do it this way. Let me know if you have a technical background, or if you have a less technical background, or if you consider yourselves from a different role. And for this, you can use your mobile device. If you didn't enter yet, if you did not join mentai.com yet, you can go to mentai.com and enter the code that you see in the screen, or scan the QR code. I see that some already successfully joined, well, the quiz. I'll give everyone a bit more time to join on their mobile devices. So once again, you can either scan the QR code or go to mentai.com and entering the code 62959292, and quite some people already managed to join. I have to switch context here and there, so that's a bit misleading for me, but meanwhile, I'll just continue. All right. RumVision organized this webinar today. My name is Erwin Hoffman. Well, that's how you pronounce it in English, at least. And we're with a team of, well, both developers as well as non-developers, obviously. As a matter of fact, this isn't even our latest setting. More about myself. I'm, by origin at least, a developer since 2001. Then also became a consultant, giving audits and training sessions both to merchants as well as agencies. And I'm one of the co-founders of RumVision, and actually also became a Google Developer Expert last year at the age of 37. So anything's still possible. And with that being said, let's move to the first question. Once again, you can use your mobile devices. You should use your mobile devices. And you can either pick a name and an additional avatar maybe. And I'm seeing some more people are joining. And if you didn't join, if you came in just now, then you will still get a lot of info from today's webinar. But meanwhile, let's move on. And the faster you answer the question, the more points you get. What does INP stand for? Let's start in an easy way. Is it input, negotiation, presentation delay, interaction not yet possible, interaction to next page, intermittent navigation performance, or irritating navigation pains? All right, I've got nothing to explain here. Awesome, let's move on. Second question right away. Let's see who paid some attention. The faster you answer, the more points you get. When will INP become part of Core Web Vitals? Is it February 13th, March 12th, April 11th, or never? Quite a lot of people are quick to answer. And well, I don't have a lot to explain, but I will elaborate a little bit. Today is the day that INP is replacing FID, first input delay. However, as Core Web Vitals in general is based on the data of the last 28 days, so based on real use experience of your very own website, this basically means that data as of February 13th are already part of today's Core Web Vitals, because once again, it's based on the last 28 days. So if you would want to pass INP before the deadline, you're basically too late already. You should have been able to pass it back then in February 13th. At the same time, although INP is part of Core Web Vitals and Core Web Vitals is part of Page Experience Ranking Signal, and Page Experience Ranking Signal is part of, well, yeah, SEO, it's obviously also a user experience metric, which means that although, well, let's move on because it might be part of one of my follow-up slides. But before moving to that slide, I would like to know what you think is most annoying when it comes to a website or web shop experience. You can rate all of them. And meanwhile, I'll just continue talking. In this case, looking at the white screen is equal to FCP, first control paint, which means that a user would typically look at the white screen for too long. Long loading product image is basically the LCP. Add to cart or menu interactions taking long to respond is INP. Responsiveness, you could say someone is using way too much JavaScript, for example, or rendering. And the last one is recommended products, top banners or video ads sliding down. That's, well, CLS, you could say page stability. And all of them are, yeah, so in some perspective, part of user experience, user frustration, and also page speed. Let's move on. This is basically the same metrics, but then in text, and you might have seen them already. Otherwise, I would advise to go to web.dev/webvitals. They might have changed the URL because I know they did a replatforming recently, so the URL might have changed. But otherwise, on web.dev, which is a Google, maintained by Google, is giving a lot of info about each of these metrics as well. What I would like to know is, before moving on, what do you want to learn? Do you want me to dive into technical stuff, or would you like it to be less technical, or are you not even sure? Well, a lot of technical people already, so I know enough. Let's move on. Core Web Vitals, what a ridiculous concept. This is actually a tweet that I created myself, but I did hear from people, for example, product owners, that Google is continuously changing the game. And although it might feel like that because, yeah, CLS changed over time, LCP changed over time, and now FID is being replaced by INP, it's not like it wasn't an issue before. The fact that there is a new metric doesn't change user experience. The user experience may be already sucked in the past as well. But nowadays, we just have better ways to get an idea of, well, user experience issues on our website. So, yeah, those metrics are changing continuously, but it's just giving us a better idea of any issues on your website, which might be impacting bounce, conversion, and, well, maybe even revenue. And the benefits from improving page speed and technical use experience is, well, quite wide, you could say. More visitors, lower bounce rate, etc. We even heard from people, from merchants, that, for example, their ad spend is reducing as well when they are improving page speed. Then, a bit more technical, you can also go to the YouTube URL, scan the QR code, because Jake Archibald is talking about the event loop for 1 hour. I don't have the time to do that as well, but I do have the time to elaborate on this a little bit. And what you can see, and you should be able to also see my mouse cursor, this is basically the event loop where both JavaScript tasks as well as layout tasks are picked up by the, well, yeah, event loop or browser, basically, the main thread. And an important part is the main thread is single threaded, so it can only do one thing at a time. And in this case, whenever there is a queue of yellow tasks, as you can see at the left, when there is a queue of tasks, JavaScript tasks, the browser is not able to move on to any layout task. So as long as we as developers, or maybe plugins, third parties, as long as we are queuing up more tasks and tasks, then as a result, we are basically postponing the rendering part, the styling, layout, and paint parts of a browser. And that is basically what is creating an INP, interaction to next paint. So when can the next paint happen? Well, basically when the queue is empty. And that's the biggest challenge, especially considering the fact that typically today we're shipping a lot of JavaScript, and on top of that JavaScript, there are a lot of third parties as well. So as a result, when you would see this code, and although I used jQuery, this could also be vanilla.js or whatever, when you would see this code, you might first think that a heading 1 is created with a text, and then the heading 1 is appended to the body, and that you might see the heading for an instant, and right after, we set the heading to display none. So you might expect a flickering, maybe, of a heading. However, there are 3 tasks which are all queued up, and as a result, the browser will basically, postpone. I'm saying postponing the layout part, but we are basically actively pushing the layout part back. And as a result, well, an INP is happening. Although in real life, this might take 3 milliseconds, but in real life, we are also doing way more on the main thread. We are shipping way more JavaScript, resulting in an INP. Moving on. So when we are talking about SPA single-page applications, for example, or multi-page applications, which just are non-SPAs, I hope it makes sense when saying that SPAs are more likely to have a worse INP because, well, by default, we are shipping more JavaScript in case of an SPA because all the rendering part, etc., is also done in JavaScript. And on top of JavaScript, well, as I said before, we have third parties, we have external libraries, etc., that are doing their own things. And a web shop is never done. So we continue to ship new features. And within an SPA, those features will always be written in JavaScript. While within non-JavaScript, non-SPA sites, it's more likely that additional features could either be JavaScript or server-side rendered, for example. And server-side rendered, basically, server-side rendered features are less likely to impact INP, depending on how you build them, because you might have read somewhere already that the more HTML elements you are introducing, the bigger the chance of an INP as well. All right, so this is a little joke that a Google employee actually made himself, so I found it quite funny. That's why I took a picture. I'm not the best photographer, as you can see over here. It's quite blurry. Nevertheless, this was a recent talk in Brussels, and he made a joke about how SPAs are trying to tackle performance issues, but at the same time, it is also creating maybe actually anti-patterns like this loading spinner. Talking about loading spinners, I got a question about loading spinners as well. If you are able to show a loading spinner before any JavaScript work, you are able to actually solve INP issues because the next paint is happening sooner. However, depending on how you are creating the spinner icon could freeze up, or yeah, you might also be introducing anti-patterns, because looking at a spinner icon also is not the best experience. There's always a better alternative. All right, third question, for which we need our mobile devices. I'm giving a few more people the opportunity to join, to still participate in, well, first place maybe. All right, I think we had about 30 people engaging, but let's continue. Once again, the faster you answer, the more points you get. What has the highest correlation with INP? Is it someone's internet speed, someone's device, or someone's location? Once again, a lot of people are quick to answer. And it is, in fact, well, as most people are saying already, someone's device. And if I go to the next slide, we see the result of a research that we did with, basically co-authored with Google. Because at Run Vision, we were not only collecting INP, but we are also collecting additional information from, well, basically someone's device. And it's in a privacy-friendly way, because, well, browsers do give us such APIs, but they are slimming down the amount of information to prevent any fingerprinting, for example. But what we can see here is a clear correlation. The better the device memory, like 8 gigabytes, well, the more green you see, which basically means more people had the opportunity to have a better INP experience. And the worse someone's device becomes, the higher the chance of a bad INP, as we can see by the amount of red in this chart. So yeah, someone's device memory has the biggest correlation, has a very strong correlation, in fact, with someone's yeah, responsiveness and experience on the website, and ultimately frustration and maybe even bounce. Someone's internet speed could result in JavaScript being downloaded a bit faster. However, it does not make someone's device run faster. The file itself is downloaded faster, but someone's device is not going to run any faster. Then, well, this is actually already by now an old screenshot, because as of today, Google already switched the FID metric and INP metric. Nevertheless, what you see over here is, at the left, field data based on real users. And at the right, we see basically a lighthouse report, although it has a slightly different styling maybe than when you would use it in your browser. But this is what you get to see in PageSpeed Insights. If you do not have enough visitors for a specific page that you are testing, or overall, then you would not see any field data at the left. You will not see any, well, basically, if you run a PageSpeed Insights test, you get to see field data above the fold and lighthouse data below the fold. And you would always see lighthouse data, but maybe not, depending on the amount of visitors, field data. Could you then basically lazy load all your JavaScript to fix all your issues? Well, yes, if you are only optimizing for Lighthouse, but if you are optimizing for real users, you might actually end up regressing for user experience, or at least introducing anti-patterns. What I've seen by implementing this trick is that if you start to execute all JavaScript as of the first interaction, or by, for example, 6 seconds, then all JavaScript might be executed at once and might even be batched together by the browser. And the chance of running into INP issues might even increase, because, well, more JavaScript is running at the moment of user interaction. I'll get back to this a bit later with a chart. But does this work? Does this trick work? Well, it might work for Lighthouse, because Lighthouse will stop its test after 5 seconds of inactivity on the main thread, while in real life, there is no, well, users can interact at any point with the page, and a Lighthouse will just stop at a certain point. So that's a big difference. Real user data and callback vitals will not stop tracking at page load event, but it will just continue track any events for the rest of the page. Although there are some limitations. For example, LCP tracking stops at first user interaction, but I can fill another hour about LCP and CLS, but we're only going to talk about INP today. The fourth question, and I see a lot of people already have their mobile devices with them, so here we go. Which lighthouse metric is closest to INP? Is it TTI, TBT, TTFB, or no clue? All right, I might need to elaborate a bit here. Time to interactive is both time to interactive and total blocking time are lighthouse metrics, lab data metrics. They are not tracked in the field. And INP is actually a field data metric, which is not being tracked in lab data or synthetic tests. And there is a reason. When doing a lab data test, you are not going to click. A lighthouse test is not going to click on any element, while issues could happen when clicking. And that's where INP is coming in. INP is also collecting any information from, specifically tracking information and delays from clicks or any other interaction. You could, by the way, configure Lighthouse to also interact with elements and try to simulate INP, but it's still not the same because one user might actively wait for the whole page being visible before starting to interact with the hamburger menu, while someone that is in a rush, for example, could already try to interact with the hamburger menu when the rest of the page is not really visible or when the main image is not even rendered yet. So as a result, and also depending on someone's device memory, everyone can have a different INP experience. And that's why it's hard to simulate INP in synthetic tests. Time to interactive is actually a metric that is showing the time when Lighthouse stopped tracking the rest of the page. And as a matter of fact, time to interactive is already removed from a Lighthouse test. If you would do a Lighthouse test today or a month ago, you would not even see time to interactive anymore because also Google acknowledged that time to interactive was not the best metric. Total blocking time, however, total blocking time is, it's basically already describing what it's doing. It is accumulating, all blocking periods where the blocking period was longer than 50 milliseconds, because anything that's below 50 milliseconds cannot really be perceived by users anyway. So we get 50 milliseconds per blocking period for free. When a blocking period is longer than 50 milliseconds, it is taken into account when it comes to total blocking time. And the INP threshold is 200 milliseconds. So that's the main difference. And the time first byte is actually the server response metric. It is telling us when the first byte arrived in the browser, which is not even related to TBT, TTI, nor INP. All right, total blocking time versus INP, and I already discussed most of them. As a matter of fact, I also posted this question as a poll on LinkedIn. But I already covered everything here. Total blocking time really is Lighthouse metric, while INP really is a field data or core web vitals metric, and real users cannot really be simulated. So that's why there is no INP metric in Lighthouse. Okay, this is more technical, although it was already technical up to now. But this is even a bit more technical. But describing this might help you understand what INP is. Because INP really exists of 3 phases. And this is also allowing me to describe why FID, a lot of abbreviations here and acronyms. But this is also helping me describing why FID was not a good metric. All right. Let's assume that if my mouse is working, let's assume that we want to enter a key or maybe click on the hamburger menu. And specifically during that moment, when I try to click and you see a dashed vertical line, let's say that I'm clicking here and at that moment Hotjar was executing, or maybe a chat widget or a hydration on an SPA. If that is happening at that moment, then I can try to click. The user can try to click, but the browser is not able to respond because it's still busy and stuck on another JavaScript. So before being able to come back to my interaction, the browser first has to finish its previous work, and that's the input delay. And as a matter of fact, this part, the input delay, was what FID was tracking. While, as you can see over here, there is way more work to be done for the browser. So that's where FID was lacking, you could say. So INP really is a way better successor. And then once I clicked, well, there could be an input delay. There might not be an input delay all the time, but it could be an input delay. And then the browser needs to, well, maybe, yeah, execute my event listener. For example, if I click on the hamburger menu or add to cart, some JavaScript needs to add something to my cart or add a class to the hamburger menu to actually show the navigation. So that's the key down and key up, and any processing time, any JavaScript work that lies well within those event listeners. And then once some JavaScript was executed, the page needs to be updated as well. So some rendering and painting work is involved, and that's the presentation delay. And once that is done, we can see yet another dashed line going to the top. That's where the next paint is finally presented to the user. And that's basically what INP is, interaction to next paint. When does the interaction happen? And what's the full delay, the full duration to the next, I should say, next opportunity to show a paint, because there might not always be a new paint involved. I hope that specifically this concept is already helping you understand what INP is. Meanwhile, let's move on. Because how to track INP? Well, you could use Lighthouse, but as I explained before, you might see some gaps. And even if you would see, even if you would use Lighthouse, there's not a challenge. Most of the time, you would not really see the input delay, but you might only be tracking the processing time and rendering updates. So you might not track the full INP. Additionally, if you are using Lighthouse, most third parties will still be behind a cookie notice. So using Lighthouse, you might either want to configure it differently to also accept cookies, or accept the fact that you will not track full INP issues. Because once again, if third parties were not executed, then there is obviously less JavaScript going on the main thread, and you would see better results than in real life. As a result, it might be possible that if you would test a web page, a typical e-commerce page with a lot of third parties in Lighthouse, that a lot of third parties are not executed, and you get a better score than you would see in Core Web Vitals data, for example, or Crux, Chrome User Experience data. I might need to elaborate a bit on Crux data. And I'm not sure if I've got a screenshot of this, but let's go back a few slides. And here we go. So Crux data is based on real users. And when I say real users, I should slim it down a bit, because that's what Google is doing as well. Crux data, Chrome user experience data, is maintained by Google, is one big Google database, you could say. And they are basically collecting data from real users, real visitors, from Google Chrome, although Safari excluded, or iOS Google Chrome excluded, but only when users are logged in. Because my experience, if I would visit the web shop now, my experience is submitted to Crux database, but once again, only if I'm logged in, because only if I'm logged in, I have syncing enabled. Although you could disable it, and then your experiences are not part of Core Web Vitals. So that's an interesting and important nuance. Whenever you are looking at Crux data or Core Web Vitals data in either PageSpeed Insights, Google Search Console, or any API, Crux API, it only contains data of Google Chrome, logged in Google Chrome users. However, at the same time, all Chromium browsers, which means Edge and Opera as well, also support LCP, FID, CLS, FCP, and INP metrics, although FID will be removed in 6 months' time. But all Chromium browsers also support those metrics. So if you do want to track more than just Google Chrome, you can by using either the official Google Web Vitals library or using a RUM solution. All right, let's move on. Which is what I'm showing over here as well. You could use Lighthouse, you could use DevTools and Performance Panel, for example, or you can use RUM solutions and specific APIs. And when talking about APIs, a new API that is landing in Chrome 123 is the long animation frame API. And this is a deal breaker. And I hope I'm able to show this in one of the following slides. But let's first move on how to pass INP. All right. I already talked about delaying all our JavaScript, but that's actually introducing anti-patterns. So that's not the best way. We could buy all of our visitors the latest iPhone, because we already learned today that the faster our devices are, or I should say, the faster the devices are of your audience, of your website's audience, the better your INP could be, because it still depends on the amount of JavaScript, etc., that you are shipping. However, if everyone is using iPhones, then we would not even have Core by Vitals data, because we already learned as well that Core by Vitals data is only coming from Google Chrome. Nevertheless, there are still some ways that you could, improve INP, reduce initial JavaScript work and rendering work. And when talking about rendering work, you might recognize when I say that you should reduce the amount of DOM nodes. Because, and I hope it makes sense, the more elements you have, the more elements that needs to be painted as well. And as a result, if the browser is stuck on rendering work, that also takes a bit of time. I should add that most of the time JavaScript is to blame. You might have a bigger chance of having JavaScript issues than layout issues, but fact is there could also be rendering issues. And as I'm saying over here as well, you could also use smart JavaScript versus CSS. What I'm saying here is, and I just published a playground on my own site as well, erwinhoffman.com, with some demos, and I created the demo myself as well, which is clearly showing, and I might have some time to show this later on, that if you are able to use CSS instead of JavaScript, that you should use CSS, because once again, it is clogging and blocking the main thread less than when you would use a JavaScript equivalent. And marketing decisions, obviously. When you picking a lightweight alternative to whatever A/B testing solution, the better your INP becomes as well, which makes sense. But how to really fix it? There are a few, I would not really call this quick wins, although the content visibility CSS property might be a quick win. The other ones take a bit more time to implement, unfortunately. Nevertheless, content visibility is an awesome one-liner CSS property to tell the browser to skip rendering work for that specific element and any child elements. So 2 examples. If you've got a very big footer with a lot of links, or a very big mega menu with a lot of links within that menu, then content visibility could be a good candidate to implement and improve rendering work. It is not fixing any JavaScript work, but at least it could already reduce the style and layout phases within the browser. Request animation frame could be worthwhile to experiment with when dealing with animations. Scheduler yield is a new API only working on Chromium browsers, unfortunately. So that's something to take into account, but it is a deal breaker as well. And once again, do less with JavaScript when you have that opportunity. I'm moving along because we only have 10 minutes left on paper. This is a performance panel. And as I said in the beginning, it might be a bit overwhelming. In my first few years of performance consultant, it was even overwhelming to me as well. But it is being updated and improved by the DevTools team, with, as a result, making it easier to read and to align any issues going on. One example is the so-called whiskers. And you can see short lines along the pointer interaction. So let's use my mouse cursor as well. You can see a very slight, small whisker at the left, then the pointer event itself, and any work within that pointer event, and then pointer interaction, I should say, and then a longer whisker at the right. And that's basically clearly, telling us, but also helping us developers or consultants, or in whatever we're working, it is helping us to align things way better within the performance panel, making it, I would say, less overwhelming and more clear than before. As a matter of fact, when you would hover over this specific interaction, it would even show a tooltip describing each of these phases as well. Input delay, which means I was still stuck for 1 millisecond on another task. Then the processing time, that really was the click event listener, for my specific interaction. And then the presentation delay, because although the JavaScript part was done, there is still some layout, style, and paint work to be done. And that takes a bit of yeah, that also takes a bit of time. So this is an awesome update. I think it was in Chrome 121, so it's already stable. Moving on, because in the end, you can't improve what you don't measure, and that's where both field data and core web vitals, but especially the LOAF API, long animation frame API, comes in. And Google is even saying the same. You should, if you are able to do so, you should collect INP in the field as well. Well, you only have the option to collect this in the field, but by collecting it in the field, you get more insightful information to actively debug INP issues. One example specifically within RUM Vision is this specific dashboard. Because any RUM tooling, well, yeah, basically like any tooling out there, any new tooling can be overwhelming. A new RUM tooling could have a lot of information to digest. And what we try to do is introduce a new dashboard, which we call third-party dashboard, for less technical stakeholders like product managers, product owners, marketers, lead developers, whatever, to start this discussions about basically about the correct third parties. Because it's still guessing work, I guess, when using Lighthouse, while you would actually want to optimize those that come with an impact. And that can be done with the new API, the so-called LOAF, Long Animation Frame API. It is giving us the exact hostname as well as the exact file and actually, as a matter of fact, also the exact character number that is causing INP issues, or I should say, long tasks. And with that kind of information, we can really start to make the right decisions. For example, should we maybe remove heat map and replace it with clarity? Should we actually use Hotjar? Is tracking someone's mouse behavior, is that actually a good idea, etc.? And once again, I cannot emphasize this enough. That is what you can do with the long animation frame API. So you could either use it yourselves or pick a RUM solution that is already supporting this and able to show you the impact of all of your third parties, but also first party. If you typically have a lot of JavaScript or hydration work, LOAF is able to collect that as well. Last question. So I'll be sure to wait a bit for about 30 people to join. All right, here we go. The faster you answer, the more points you get. What is the best CSS property to animate elements? Is it margin top, padding top, or transform? 3 seconds left. All right. Well, what's the deal here? Let's elaborate a bit on this. It's not like browsers did not try to improve performance themselves. And as I have some time left, I am going to one of my own articles. So let's do that once again. There we go. And then using my own chat widget to maybe find my responsiveness fit or INP article. Oh. Yeah, this is it. All right. So this is quite a clear demo, I hope, to demonstrate any input delay issues or responsiveness issues. So let's assume that when clicking on the 2 seconds, I'm then deliberately blocking my main thread. And because this experience is tracked as well, I'm actually, as a matter of fact, also impacting my own INP, my own core web vitals. Nevertheless, it's still helpful to demonstrate INP. So let's do this. I'm going to block my main thread for 2 seconds and then try to interact with this simple checkbox. This is just a plain HTML checkbox, no JavaScript involved. So let's block my main thread and now click on the checkbox, and you only saw it unchecked, being this, unchecked after 2 seconds. And you could see that the green square, well, basically kept animating while the red square was blocked. And the reason is, well, quite simple. I'm using transform property to animate the green element, while I'm using margin left to animate the red square. And as a result, because using transform, the animation is offloaded to the GPU. That's a free optimization that browsers are doing out of the box for us. However, the browser cannot do this for all CSS properties. For many CSS properties, as a matter of fact, only opacity and transform can be offloaded for free to the graphical card instead of CPU. So if something else is running on the CPU, like, well, like this infinite loop of 2 seconds, or a third party that is showing up on the main thread, then let's do 5 seconds. I cannot, once again, I can click on an element, but the browser just is not able to come back with a visual feedback, as you can see over here. One other optimization that browsers did by themselves is, let's once again block the main thread and then scroll. I can still scroll, and that's something that browsers optimize themselves as well. Browsers are basically creating snapshots of what was happening before, above the fold and below the fold. However, I cannot zoom in and zoom out. Let's do that as well. Here we go. My hands are off the keyboard now, and only about now you could see that the page was zoomed in a bit. Because this actually involves an active repaint of the page. And then we depend on the main thread and what is happening on the main thread. And if the main thread is blocked, the browser just cannot do anything else. All right, let's move on. And let's see, as of the last standing, what the updated leaderboard is. Congrats to Kathy. All right, I'm only seeing one thumbs up, so I assume that's Kathy. Let's proceed to the last slide, and then if we have some time left, we have 2 minutes left. We can maybe jump to one other demo. Otherwise, if this was already too technical or you're on a tight schedule, then I would say thanks for watching so far. Let's see if there are some questions in the chat. I don't think so. Not really. All right, let's move on to this demo. I created, once again, on my very own site, I created another demo myself, and I actually started to create this demo to, well, allow me to understand, first of all, the so-called whiskers myself as well, and see the correlation of the whiskers with my performance panel. And creating such a demo, if you're a developer, I would really advise you to, well, create your own demo maybe to get a bit more acquainted with the performance panel. Because it really helped me to understand what was happening and where JavaScript issues are coming from and how the browser is, well, yeah, basically has to deal with that JavaScript. And we can see that at the bottom, I should say, at the bottom of the page. Okay, let's zoom in. I'll zoom out a little bit. Here we go. First of all, going to your performance panel. If you haven't done that before, you just inspect the page. And in DevTools, you've got different panels. Web.dev also has articles on this. You go to performance panel. You can do a recording. As a matter of fact, let's do that. And let's first elaborate on what kind of demo this is. You can see that the text over here is not balanced. And back in the days, we did not have a CSS only property to fix this. Nowadays we do, but back in the days we did not. And we could then only use JavaScript to align this text, to balance this text. And that's what this demo is doing, and the differences between those two scenarios, using either CSS or JavaScript to align and balance your text. So let's start recording. Let's first of all use 120 items, because the more items there are, the more CSS, but also more JavaScript needs to be done. And that gives a better demo maybe. All right, let's then start recording. Here we go. Let's then try to, well, let's use the JavaScript, and let's then also try to click over here. And once again, this can be quite overwhelming, although you can zoom in. Nevertheless, we can see quite some work being done on the main thread, and I'm actually on a fast device currently. And I also have a slower device in my office. And if I would actually do the same demo on my fast device and slow device, I get different results because, well, we already learned it also really depends on the device CPU. And if I scroll to the bottom, I have some pre-work over here. Here we go. All right. So this might look like it is taking a lot of time, but this was done, I think, with 20 elements that needed to be repainted. And it is only taking 20 milliseconds when I'm using CSS. It's only taking 20 milliseconds because, well, a function has to be executed, balance text via CSS. That is adding a class, as you can see over here, add. And once a class is added, obviously, some new rendering needs to happen because something changed in the layout. So that's where the styling and layout and rendering work, the paint work, is involved. That takes another, as we can see over here, that takes another 8 milliseconds. So that's all quite fast, as expected. But once we switch to JavaScript, then the timeline would look like this. And I needed to zoom out a bit, and then I would see some work for 300 milliseconds. And you can now clearly see all the little bursts, I would say, and this is why it's called a flame chart, because it looks like an upside flame chart. But you can see all the individual bursts for every individual element that needed to be recalculated, because now I am using JavaScript to, well, yeah, calculate the position of the new words to balance the text nicely. And once again, this is the result. I can see over here that I used 12 elements, so that's why you should see 12 bursts. And it's now quite clear to understand how JavaScript work, even within this simple demo, is then already taking up way more time. And this was actually done on my old device, so it had a worse device memory. But it is then already clearly illustrating how JavaScript work instead of CSS work is actively blocking the main thread. And then the additional paint work does not take a lot of time. It was especially the amount of JavaScript work that was blocking the main thread. So we can over here at the end of the task, we can see some paint work and rendering work. Well, a lot of rendering work is done in between, by the way. But the paint work to finalize things is only taking 4 milliseconds. In the same task bar, you can see some, well, basically some red lines on top of the gray task. And that's illustrating that this task was taking too long. So whenever you would see such a, well, red bordered pattern on top of your task, as you can see in our task as well, it is a clear signal that there was a long task. As a matter of fact, there were 2 long tasks over here. One of them was profiling overhead because I'm now debugging. And we get 50 milliseconds for free. That's why not the whole task has a red pattern. The start of the task is gray, and then the rest of the task has a red pattern, because that's when it is more likely to become a responsiveness issue. All right. I have nothing more to say, so let's wait for any questions maybe. If you do want to have a demo covering the opportunities and added benefits of RunVision, you can, well, yeah, either scan the QR code or go to runvision.com/demo and actually start debugging INP in real life by using the LOAF API. And as I said before, you can also use the LOAF API within your own DevTools in your JavaScript console, or, well, as I said before, you can also use a RUM solution that already embedded both INP and LOAF. All right, just checking if any questions are coming in. Add a spinner in a checkbox square. You could do so, by the way, and it could actually help in real life as well, because if you prioritize the visual update by, well, yeah, first showing a spinner, a subtle spinner within the checkbox, and then yielding the JavaScript work, yeah, you are actually able to improve INP at the same time. Would you use a web worker to load third-party JavaScript? That's quite a debatable topic, I would say. I've seen people trying to use it, but I've not really seen use cases where they were actually able to prove the added benefit. Obviously, Partytown is an example, and Partytown did write some use cases, but I offered Partytown to use Run Vision because we are able to track LOAF as well. But unfortunately, they never responded. But if you would use LOAF at the same time, you are actually able to prove the wins from using a web worker. However, do consider the fact that a web worker will also introduce a bit of overhead because, well, yeah, the web worker has to be booted as well. So it comes with a little overhead, but if you are able to ship a lot of third parties to a Partytown or a web worker in general, then it could pay off. But I've seen a lot of merchants struggle with using web workers and moving third parties to web workers because only third parties that are not manipulating the DOM are, I would say, a candidate to move to web workers. So that's already limiting the amount of third parties that you can move to web worker. What is the best way to measure INP on a local environment? I would say the official Web Vitals library. So if you would go to, or basically Google Web Vitals, let's use Web Vitals JavaScript library, then you could use this in staging environments, for example, and track it yourselves. As a matter of fact, you could even use Web Vitals with Google Analytics 4, for example. But if you're not a do-it-yourself type of user, then you could still use a RUM solution. Any general ideas, insights with regards to cookie banners on INP? I do. And the sad part about cookie banners in general is, they are involving quite a bit of JavaScript. Could sometimes even cause both INP and CLS issues, especially unfortunately, the bigger cookie notices. But I do know that Google is not really working together with them, but is trying to force CMPs to focus on INP and CLS as well. And in some cases nowadays, you really need a registered CMP. So normally back in the days, I would advise to maybe create your own to limit the impact of INP, of a cookie notice on INP and CLS, but that's not really an answer anymore today. Yeah, it's unfortunately really the responsibility of a CMP themselves. All right, I'm not seeing any new questions coming in, so I'm calling it a day, and thanks for joining.